Now, how do we find the derivative of x to the power of 5 plus y to the power of 5 plus 3xy to the power of 3 equals to 8? Please pay attention. We are differentiating y with respect to x. So anytime you differentiate y, you add dy dx. Okay? So if you differentiate x raised to the power of 5, you're going to have 5x raised to the power of 4 plus differentiate y raised to the power of 5, you're going to have 5y raised to the power of 4 dy over dx plus 3. Leave the bracket. Okay? Now pay attention. Let us differentiate xy raised to the power of 3. This is u and this is v. You understand? And according to product rule, we are going to keep u constant, which is x, differentiate y, which is 3y raised to the power of 2, multiply it by dy over dx, then put the additional sign. Now we are going to keep v constant now and differentiate u. If you differentiate u is x, and if you differentiate x, you're going to have 1. So I'm going to have 1 multiplied by y raised to the power of 3. Okay, so I'm going to have x 3y squared dy over dx plus y raised to the power of 3. Now x 3y squared can be written as 3xy squared dy over dx plus y raised to the power of 3. Okay, so all you have to do now is to replace, since, see, let me tell you, what I did here is that I put this plus 3 that you see here, I put it here. So I take the derivative of xy cube, and that's the derivative of xy cube, just like we did for the earlier question. You understand? So the derivative of xy cube is 3xy squared dy dx plus y raised to the power of 3. So here I'm going to have 3xy cube y squared, sorry, y squared dy all over dx plus y raised to the power of 3. Okay, so is equals to, now if you differentiate a constant will give 0. So if you differentiate 8 is a constant. If you differentiate it, you are going to have 0. Okay, now let us proceed. Since we are done with this, I can erase it. Okay, so here I'm going to have 5x to the power of 4, 5y to the power of 4 dy dx plus, okay, let's open the brackets using plus 3. Plus 3 times 3xy cubed y squared dy dx. That is 9xy squared dy dx plus 3 times y raised to the power of 3. That is plus 3y raised to the power of 3 equals to 0. Now, the next step is that you have to connect like terms. The terms that are similar to each other. Those terms that have dy dx attached to it, you leave it to the left hand side, and those terms that do not have dy dx attached to it, you take them to the right hand side of the equation. You can see that 5y raised to the power of 4 has dy dx attached to it, so you leave it there. Likewise, 9xy raised to the power of 2 has dy dx attached to it, so you leave it here. But 5x raised to the power of 4 and 3y raised to the power of 3 will be taken to the right hand side of the equation. So we are going to have 5y to the power of 4 dy over dx plus 9xy to the power of 2 dy over dx is equals to, okay, if this positive 5x raised to the power of 4 crosses the equals to sign, the sign is going to change to negative. So I'm going to have negative 5x raised to the power of 4. And if this positive 3y raised to the power of 3 crosses the equals to sign, the sign is going to change to negative as well. So I'm going to have negative 3y raised to the power of 3. Now, pay attention. The next step here is that we have to factorize. Dy dx is common to both sides. So I'm going to have dy over dx 5y raised to the power of 4 plus 9xy raised to the power of 2 is equals to negative 5x raised to the power of 4 minus 3y raised to the power of 3. Now, the goal is to find dy dx. So I'm going to divide both sides by 5y raised to the power of 4. Why? Because the goals of the question is to find the derivative of y with respect to x. And I have 5y raised to the power of 4 plus 9y raised to the power of 9xy squared attached to dy dx. And in an attempt to help dy dx to stand alone, I have to divide by this. So I'm going to have 5y raised to the power of 4 plus 9xy squared all this also divided by 5y raised to the power of 4 plus 9xy squared. Okay, so here I'm going to have the y all over the x is equals to negative 5x squared, negative 5x raised to the power of 4, negative 3y raised to the power of 3 all over 5y raised to the power of 4 plus 9xy squared. Okay, so that is the solution to that question. I'm very sure you understand. Now, you see, this question is simple. All you have to do is just, you have to pay attention to the details when you are solving the question. Let me tell you the basic principle. I've told you in our previous class or so. Anytime maybe you are differentiating something with respect to another thing. What you are differentiating, anytime you differentiate it, if that function is an implicit function, add the derivative of that thing with respect to what you are differentiating with. Now we are differentiating with respect to y. So anytime I differentiate y in this function, I'm going to add the y dx. Do you understand? That's the basic techniques with respect to searching the how to differentiate an implicit function. Now we have the last question, which is x plus y sine y. Okay, we have the last question, which is x plus y plus sine y equals to 3. Now, how do we find the derivative of that function?